State the equation of the image graph if y equals tan of x undergoes the following transformations. So the first thing that happens is that it is dilated from the x-axis by a factor of 3, followed by a dilation from the y-axis by a factor of 2, followed by a translation of pi on 2 units parallel with the positive x-axis, and finally it's translated 4 units parallel with the negative y-axis. So to help us perform these transformations, we're going to use mapping notation. So we're going to have x, y maps 2. And now the first thing that happened was it was dilated from the x-axis by a factor of 3. So when we dilate from the x-axis, we're affecting the y value. So if we have x, y, the dilation by a factor of 3 from the x-axis will be 3 multiplied by y. For the second thing that happens, we have a dilation from the y-axis by a factor of 2, which is multiplying the x by 2. Next, we're going to deal with our translations. So we're going to still have 2x, and now we're going to translate it pi on 2 units parallel with the positive x-axis, which is the same as adding pi on 2 in our mapping notation. And then we're still going to have 3y, but now we're going to translate it 4 units parallel with the negative y-axis, so we're going to have subtract 4. So that's the mapping notation for this sequence of transformations. What we do now is we pull two equations out, so equation 1 and equation 2, and this is x here is x dash, the transformed x is equal to 2x plus pi on 2. So we have x dash is equal to 2x plus pi on 2. And for the second equation we have y dash, the transformed y value, is equal to 3y minus 4. Now what we need to do is solve for the non-dash term. So we need to solve for the x and the y that doesn't have a dash on it. So for equation 1, we're going to start by subtracting pi on 2 from both sides of the equation. And that will give us 2x is equal to x dashed minus pi on 2. And then we're going to divide both sides of the equation by 2 to get x by itself. So we will find that x is equal to, and I'm just going to leave it as a half, times x dash minus pi on 2. For equation 2, we're going to start by adding 4 to both sides of the equation. So we find that 3y is equal to y dash plus 4. And then to get y by itself, we're going to divide both sides of the equation by 3. Therefore, y is going to equal y dash plus 4 divided by 3. The next thing we need to do is sub what we've just found into our original graph, which was y equals tan of x. So that means wherever there was a y in the original equation, we're going to replace it with the equivalent expression we found before. So we're going to substitute in y dash plus 4 all divided by 3, and that's going to equal tan, and wherever there was an x, we're going to replace it with a half times x dash minus pi divided by 2, which is what we found previously that was the equivalent x expression. By convention, we always express our equations as y equals, so we're going to multiply both sides of this equation by 3, and that will give us y dash plus 4 is equal to 3 times tan of a half times x dash minus pi on 2. Finally, we only need to subtract 4 from both sides to get y by itself. And our new equation, which we could call y1, and at this stage we can leave off our dashes because we now have a new equation y1, is equal to 3 times tan of a half times x minus pi on 2 minus 4. So this is the equation of the image graph after the transformations were applied.